Can you hack sudo? Sudo, or super user do, is a program that allows you to run privileged commands in Linux, like apt, for example, to install packages. Now, sudo has been the target of multiple CVEs, and you know what? They found another one. Sudo. A flaw was found in sudo. This flaw allows a local attacker to escalate their privileges by tricking sudo into loading an arbitrary shared library using a user-specified root directory via the chroot option. A bunch is going on here. Let's break it down. Before we keep going, let's hear a word from today's video sponsor. It's me. Yep, it's me again. You guessed it. Okay, here we go. Guys, I honestly believe that if you're a programmer trying to write fast, effective code, or you're a cybersecurity professional trying to stop your stuff from getting attacked, all of these require you to know the basic fundamentals of computers. My courses on Low Level Academy teach you languages like C, networking in C, threading in C, assembly, and even a new installment, Rust, to learn the basics of how computers work. And Zero to Hero C programming will teach you the basics of the C programming language, the language that runs all other languages, and you can even learn arrays in C right now for free. Go check that lesson out. If you want to learn assembly, my ARM load operations lesson is also free, and I also have a free 3-day C course that you can check out right here on the landing page. Guys, if you want to be a good programmer, you got to know the fundamentals, and where do you learn the fundamentals? On Low Level Academy. All right, guys, back to the video. See you there. What even is sudo? So when you want to do privileged things on a Linux box, you have to run sudo, or super user do. This allows you to escalate the privilege of that process temporarily to root, so you can do privileged things like run apt, the apt package manager, to install something.dev, right? The way this actually works is sudo is just another program. It is literally a binary that runs in user bin sudo, and it is marked as setuid. What this means is it tells the kernel, hey, when this program runs, I want you to escalate the process that is running that program to the user that owns it. And who owns this process? Root. So when I do, for example, just the command sudo, even though I'm just printing out the usage of sudo, during this usage process being ran, it is running as root. Now, this is the reason why sudo has become the target of so many privilege escalation vulnerabilities, is because I can just run sudo and access parts of the program, and it's all being ran as root. A single parsing vulnerability or logic issue in the way that sudo is designed will allow me to take advantage of it and exploit the process as root. Now, this is the exact nature of this vulnerability here. It all stems from two features within sudo: the chroot option and sudo's use of this thing called NS-switch. If you don't know what chroot is this idea of creating effectively a file system jail, right? So if I do ls/, what I'm looking at here is the root of my file system. There are no files at a higher level than root. Now, what I can also do is I can create these things called chroot jails. I can temporarily tell the shell that I'm in that there are no more files higher than a specific folder. Like, for example, if I do sudo chroot jail, the process that I'm in, bash or zsh, will think that jail is now root. Now, the reason this inevitably fails is because inside of jail, I need to not only have all things required to run an effective environment like a shell, I also need to have all of the libraries that are associated with the environment, like libc, libm for math, etc. So this will fail for me. Now, the second part of this is this file called NS-switch, or name service switch. The way this works is in Linux, when you want to do things that are associated with users, that are associated with passwords or groups, there are kind of multiple places that it can source that information from. So the one is the file system. Obviously, you have the etc password file, and for shadow for your passwords, there's the etc shadow file. But there are also other places like the systemd service manager that you can also source that data from. Now, when you use that data, libnss has an associated shared object that is used to handle that implementation of the name service. Now, this shared object is just code. So what if we could modify the NS-switch file to point to our own code using a chroot in sudo? What this would do effectively is escalate our process to root. We would use the chroot to tell the file system that, hey, etc NS-switch is actually our own version of NS-switch. And then when it goes to get the files library for NSS, we can actually put our own code there and run it in the context of sudo as root. This is exactly how the proof of concept for the CVE works. There's a lot of boilerplate up top, but effectively what the researchers did here, and again, the researcher that I'm talking about is Rich Merch, so go show him some love on Twitter. I'll put his link in the description below. They write their own little mini shared object. They call it woot1337. And all this does is it creates a constructor, which is a function that runs before main or runs before startup in the C environment, right? And what it does is it sets the effective user ID of the process and the effective group ID of the process to 0, which means that it's running as root. And then we set the directory to root and then run some arbitrary commands. In the context of this is running as root. Now, for this to happen, the process ID has to also be root. You can't just arbitrarily set your process ID to be root, right? The way that we do this is we make our own version of NSSwitch where we say, hey, any password information, any information related to figuring out the user information of the system is going to be a woot1337. What this will do, this will now tell the file system to look for libnss woot1337.so.2, which is just a shared object. It is just code. So what we're going to do is now chroot to the woot directory. We're going to put ourselves into a chroot jail so that when it looks for etc NSSwitch, it's actually going to get our version of NSSwitch. Then when sudo goes to execute any password related functions, it will instead run our code as root, giving us a shell. And luckily, the researchers here did a really good job of, they built the proof of concept in Docker that we can use. So I'm in the Docker image right now. So, this is just the POC that I just showed you guys. And if I run this again, so if you look at a few things, first of all, etc group, I am not in the sudo-rs group, which means that I can't just sudo root. What the sudo command actually is doing here is I'm not doing a sudo su. I'm not escalating to root. Super user do can actually just be used to load as a different user, right? So I can do sudo as a person, right? Or sudo as whoever. And I can also do the tac-r command, which puts me into a chroot jail. It says, hey, run this command as this person in this jail. There's actually another bug in this. It's kind of weird. So because we have a slash in the name of the shared object, the way that the process for libnss will actually open this file, it won't look in the top level libc LD library search path. It will instead just look locally. Again, this is another bug in dlopen that's not a bug, misimplementation in dlopen that's associated with this. Not super important for this. So what you do is you run the chroot on woot, and this command doesn't matter. It could be Steve or Frank. This is just at the point that this runs, it will eventually load our shared object and get us as root. And so we have the Docker image here. If we run this, bada bing, bada boom, woot, we are now root in this Docker image. Kind of a crazy exploit. The reason why this is so neat, guys, is there is no memory corruption. There is no vulnerability that is associated with oh, there's a buffer overflow in the heap in sudo and I have to leak ASLR and there's no craziness. It's literally a logic bug, a misimplementation of trust boundaries in sudo that allows us to execute code as root. Now, this is incredibly interesting because if you're new here, maybe, you remember I was talking about the adoption of sudo-rs as default in Ubuntu in 25.10. What this is the reimplementation of sudo in Rust as the default for Ubuntu going forward in 25.10. Now, this is a very contentious topic. People tend to either love or hate. There's no middle ground. Rust. But Rust is unequivocally a memory-safe programming language, so you would think oh, CVEs in sudo should go away if it's written in Rust, right? And ironically, this vulnerability would not have been stopped if this were written in Rust, right? Because this isn't a vulnerability that stems from an out-of-bounds read or write that would be protected by Rust. This is a vulnerability in the way that sudo handles its chroot option and the associated downstream effects of that, right? If I were to run this version of sudo as written in Rust and do this exact attack, in theory, it would still have the same effects because I'm not exploiting a memory buffer. I'm literally just saying, hey, can you use my version of NSSwitch? Oh, and by the way, can you use my shared object in this chroot jail? And then boom, that pops us up to a root shell. Now, guys, I do have a whole other video on the adoption of sudo-rs, so go check that video out right here. It's super interesting, and I think it's good for everyone to know the nature of sudo going forward. Maybe it'll stop some bugs, maybe it'll stop no bugs. I have no idea. Let me know what you think. Go check that video out. We'll see you there.